question number 1, hydrogen iodide dissociate to form iodine and also hydrogen gas. If the concentration of the HR changes at the rate of 0.45 molar per second, what is the rate of appearance of the iodine? So when you get this kind of question, the first thing that you need to do is you need to write the balance equation. Given in the question is that this HI will dissociate into iodine and also H2. So when you want to balance this equation, you need to make sure that the number of iodine and the number of hydrogen at the reactant should be balanced with the product. So at the product, both of these elements, you have 2 molecules, so you need to add 2 around here, and yeah, you will get the balance equation for this reaction. Okay, up next, so you were asked to find the rate of appearance for the iodine. So when you want to write the rate of appearance, means that you want what you need to do is that you need to write the rate expression. So rate expression is equivalent to, okay, you need to differentiate between the reactant and also the product. So whatever in the reactant must have a negative sign, because the value of the reactant or the amount of the reactant will diminish as they are producing the product. So now, because you have 2 here, we are going to write 1/2, right? And then you will have delta concentration of HI over delta T equivalent. So make sure that you write equivalent, not bigger than, or not you write a rate again. So it's equivalent to delta concentration of iodine delta T equivalent to delta concentration of H2 delta T. Alright, what are other things that you know from this question? So it states here that if the concentration of the HI changes at the rate of 0.45, so this one, the concentration of HI is 0.45. So you were asked to calculate the rate of appearance for the iodine. So the thing that you need to look at is just these 2, which is this one and also this one, right? So since you were not asked to calculate this one, you can omit this. Okay, and then so you just have to write again. Whereby in the question it states here that the concentration of the HI is 0.45. So 1/2 times 0.45 is equivalent to delta iodine over delta T. So you just have to press your calculator to find what is the value of this. So you will get 0.2250 molar per second. So this is your final answer for the first question. Question number 2, the initial rate data for the reaction of 2N2O5 will produce 4NO2 and oxygen is shown in the following table. So this table, determine the value of the rate constant for this reaction. So this is a rather straightforward question, because given to you is only 2 experiments, so you don't have to change or to choose anything. So first and foremost, what you need to do is you need to find the value of the X. So from your X, then only you can grab the value of the K, which is the rate constant. So in order for you to get the value of X, because here what you can know is that because you only have like one reactant, in the rate law you only look into the reactant, not the product. So in a way, because you only have one reactant, so the rate is equivalent to K N2O5 to the power of X. So it's crucial for you to find what is this value of X. So in order for you to find this value of X, you need to use the information given here. So usually I use like bigger number divided by the smaller number. So 45 divided by 22.5, so it's the rate, right? Yeah. So it's equivalent to K. This one is 2.56 times 10 to the power of 2, and the other one is 1.28 times 10 to the power of 2. So both will be to the power of X. So from here you just need to press your calculator. You should get 2.0455 is equivalent to 2 to the power of X. So we are just going to round out this number. So 2 to the power of X is equivalent to 2, so your X is equivalent to 1. Right. So from there, you need to calculate the value of K, because in the question you were asked to calculate the rate constant for this reaction. So rate constant, so you just have to copy this one again. So rate is equivalent to K, concentration of N2O5 to the power of X, whereby the value of X is equivalent to 1. So you can write rate is equivalent to K, concentration of N2O5. So the concentration of N2O5, you can use either one that you want to use. So I'm just going to pick experiment number 2, which is 2.56 times 10 to the power of 2 to the power of 1, where the rate is 45. So you should get the value of K is equivalent to 45 divided by 2.56 times 10 to the power of 2. You should get 0.1758, so per second. So this is your final answer for the second question. Question number 3. What is the percentage of the material shall persist after 80 minutes if its half-life is 20 minutes and the reaction follows the first order reaction? So for this kind of question, the first thing that you need to do is you need to find the value of K, which is the rate constant. But since this one is following the first order reaction, so we are going to use the value that is given to you in the question. So the first value given to you is the half-life of this reaction. So the half-life of this reaction is 20 minutes. So for the first order reaction, the half-life is equivalent to ln 2 over K, where the half-life is equivalent to 20. From here you can calculate the value of K is equivalent to 0.0346. So this is your value of K. The first order reaction is equivalent to ln AT equivalent to negative KT plus ln A naught, where the A naught is the initial concentration and the AT is final concentration. If you look back at the question here, so what happened after 80 minutes and you already calculated the value of K. So the value of K is for this, so negative 0.0346, and the time 80 minutes, so the time is 80. Okay, what is your initial concentration? Initially, the concentration of your reactant should be 100%. So 100 divided by 100 equivalent to 1. So you should be able to calculate the value of the final concentration. So from here you should get the value is negative 2.768. Therefore, when you want to calculate the concentration, the final concentration, which is the 80, you should get the concentration of the 80 is equivalent to 0.0627. Alright, we look back at the question. So the question states that what is the percentage of the material? So you want to find the percentage of this. So it means that you need to times 100. So 1, 2. So therefore, it's going to be 6.27%. So this is your final answer for this question.